So this is part 2 of the AS Unit 2 CCEA specimen paper. I'm going to do question 11, 12 and 13 here. Again, apologies for the panting in the background, it's my dog. She's absolutely roasting and has been chasing a ball, so sorry about that. There's not a lot I can do about the noise from her. So it's pre-filled because I want to do this as quickly as I can. I know some of you are really wanting to see this before the exam. So this first question is talking about a compound which contains carbon, hydrogen and bromine. Tells you 22.2% of the mass is carbon, 3.7 is hydrogen, and the molecular mass of the compound is 216. So what I've done here is just worked out the empirical formula first of all. So we've got 22.2, 3.7, and then the mass of bromine, or the percentage of bromine, has to be 74.1. That's just taking the other two away from 100. We're dividing through by the relative atomic mass, and that gives us 1.85 for carbon, 3.7 for hydrogen, 0.92 for the bromine. And then we divide by the smallest number, which is 0.92, and that gives us a whole number ratio of 2 to 4 to 1. And there's 1 mark for that. Then you get another mark for writing the empirical formula, which is here, C2H4Br. And then I'm working out the molecular mass for 1 unit of the empirical formula. And you see here I have 2 12s for the carbon, 4 1s for the hydrogen, and 80 for the bromine, so that's a total of 108. I take the mass of the compound that we have, divide it by that mass of 1 unit of the formula, and that gives me 2. So what I'm going to do then is multiply this empirical formula here by 2, which gives me C4H8Br2. And your 3rd mark is for giving that formula. Question 12. Petrol and diesel are both mixtures of hydrocarbons obtained from crude oil. The isomers of C5H12, which is pentane, are often included due to their capacity to prevent knocking, a problem which can lead to severe engine damage. The 3 structural isomers of this are shown below. So we've got N-pentane, isopentane and neopentane. And what I've done here is just drawn them out slightly, well, just drawn out where the carbons are on the skeletal formula. So you remember that at each end or intersection of the lines you have a carbon. And that makes it a little bit easier to draw out the structures. So first question here, A, is to draw the structural formula for isopentane and for neopentane. So isopentane is this one, and I've just done the straight chain of carbons, which is this chain here, and you see then that there's a methyl group attached to it, and it's here. So when I name it, then the longest chain is 4 carbons, so that's a butane, and on the second carbon it has a methyl group, so it's 2-methylbutane. And then the second one, neopentane, no matter what way you look at this molecule here, you know, it's 3 carbons is the longest chain. The middle carbon has 2 methyl groups attached to it, so I've just drawn that here. We've got 3 carbon chain in the middle with your 2 methyl groups, and you'll see it doesn't matter which end you count from, the longest chain is still always 3. So the 2 methyls are on the second carbon, so that's 2,2 dimethyl because there are 2 of them, and then propane because 3 is the longest chain. 1 mark for each structure and 1 mark for each name. Then it says the 3 pentanes are regarded as structural isomers. Explain this term. So all you have to say here is that they're molecules with the same molecular formula but with different structural formulae. Okay, so 2 marks for that. Then state and explain which has the lowest boiling point. So you're looking for the most branched structure. So if we go back to this table, the most branched structure here is the one that I've circled. It's the neopentane. So you get 1 mark for stating that, and then 2 marks for your explanation. So you're saying it has the most branched structure, and if it has the most branched structure, there are fewer points of contact, so it has the weakest van der Waals forces. Then we've got another combustion equation. There's one of those in the multiple choice. Complete combustion of pentane. So you're given the formula for pentane at C5H12, 5CO2 and 6H2O. When we add up the oxygens in those 5 in the carbon dioxide, 5 times 2 in the carbon dioxide is 10, and then another 6. So we divide that by 2 and we get 8. So 2 marks, 1 for getting the correct equation and 1 for getting the balancing correct. And then we're looking at the reaction in the presence of UV light, where alkanes undergo radical substitution. And then here you're being asked for the reaction between pentane and chlorine. So you probably have learnt ethane, but you're just substituting in pentane in place of ethane where you would normally use it. So initiation, of course, is the chlorine molecule being broken up by homolytic fission to give two chlorine radicals. Propagation is anywhere where you have a radical reacting with something else to produce another radical. So you see in the first one, there's a chlorine radical and pentane giving us this the radical from the pentane, C5H11, with the dot for the radical, and HCl, and then that radical going on to react with chlorine gas to give us CH5Cl and a chlorine radical. And then termination is any reaction where two radicals react together, removing them from the reaction. So two chlorine radicals giving the chlorine, two of these C5H11 radicals giving us C10H22, or one of each, the C5H11 and the chlorine radical giving us C5H11Cl. Question 13, then. Many enthalpy changes, including enthalpies of combustion, can be determined by experiment. Others can be deduced using Hess's law. So it says, first of all, state Hess's law. So two parts to that. The first part, you always have to mention an enthalpy change in Hess's law, and then it's just saying that the enthalpy change is independent of the route taken. So it doesn't matter what pathway the reaction takes, the enthalpy change will always be the same. Then define the standard enthalpy of combustion. So you always start these with the enthalpy change which occurs when 1 mole of a substance must be 1 mole, so that's your first mark. In this case, it's combustion, so it undergoes complete combustion in oxygen, so that's for your second mark, and the final mark is always for under standard conditions. Now, in the next question, I've drawn it out how I would work it out, so I hope that helps you with it. It says, use the standard enthalpies of formation given in the table below to calculate the enthalpy change for the complete combustion of methane. So, you see I have rewritten the equation here down underneath, and then because it's from enthalpies of formation, I'm not bothering to write out what all the elements are. I've just written elements because it doesn't really matter, and you just tend to get bogged down and waste time in the exam trying to work out the balancing of that. So then you're writing in the numbers, so minus 75 for the formation of ethane. For carbon dioxide, it's minus 394, and then for water it's minus 286, and you'll see I've put in here 2 times 286, not 96. You multiply it by 2 because there are 2 moles of the water in the balanced equation. Now, you see the direction of the yellow arrow. You want to make sure that everything is going in the same direction as the yellow arrow. So here the methane is going in the opposite direction, so we change the sign, so it becomes plus 75. Then minus 394 for the carbon dioxide, and minus 2 times 286 for the water. The total then is minus 891 kilojoules per mole. So in B, asks you, enthalpy changes can be calculated using average bond enthalpies. So in bond enthalpies were used to estimate the enthalpy of reaction for the complete combustion of methane. It was found to have a value of minus 698 kilojoules per mole. Explain why the value given above differs from the value obtained in A part 3. It's simply because the average bond enthalpies are used, and we know that those are different because the bond enthalpy in different compounds is going to be different, and average means that you're going to get a discrepancy when you do your calculation. So then you have to use the estimated bond enthalpy of reaction and the bond enthalpies given in the table to calculate the bond enthalpy of the CH bond in methane. So I've written the balanced equation here just to make it easier when I'm working stuff out. The methane, we're looking for the 4 bonds in it, so I've called it 4x. And then in oxygen we have we have 2 molecules of oxygen, so we have 2 times 496 here. Carbon dioxide, each molecule has 2 bonds in it, so we've got 2 times 743, And each water has 2 bonds, so it's a total of 4 bonds, so 4 times 463. So on the left hand side, 4x, which is the methane, the bonds in the methane, plus 992 is equal to 3,338 on the right. We take the 992 away from that number, we end up with 1648. And that gives us the value of 4 of those bonds, so we divide that by 4, and that gives us 412 kilojoules per mole. In part C, you're being asked to describe experimentally how you would determine the enthalpy of combustion of ethanol. So I'm just going to read the points here. To get 6 marks, you needed 6 indicative points. 4 marks was from 5 points, and 2 marks was from 4 points. So the first point is that you take a spirit burner and find the mass before and after burning, and that's including the ethanol. Excuse me, I have a horrible cold. Then you measure the known volume of water with the calorimeter using a burette. Then you burn the ethanol and use the heat to heat the water in the calorimeter. You measure the initial and final temperature of the water using a thermometer. You calculate the heat evolved during Q equals mc delta T. You calculate the number of moles of ethanol from the mass of ethanol burned, and then you divide the heat evolved by the moles of ethanol used, and that gives you the enthalpy of combustion. And finally, give 2 practical reasons why the experimental value obtained is significantly different from a value quoted in a data book. Well, you have to take into account it could be incomplete combustion, and also it's not a perfect world, so there's going to be some heat loss to the surroundings. So if you want to see the rest of the questions, I'm going to upload those later in a video of question 14, 15 and 16.